Hello everyone, I hope you are doing well. Welcome all in this new video. In this video, we will perform exploratory data analysis, in short EDA, on a diabetes dataset. So before going deep dive into video, my name is Uday Bhan and my YouTube channel name is Analyst Today. If you are someone who love data science and machine learning, then this is right place for you. You can subscribe to my YouTube channel. So let's start the video. Okay, so I have opened my PC and I have shared my screen. So you can see I will open my browser and I have already opened this notebook. In this notebook, you can see this is a Google Collab notebook, and which we will use this notebook only for this our EDA. So before running this cell, I will reconnect my notebook to runtime. Then after connecting, I will go to this and I will upload my data. So from here, I will upload my data. Then you can see this is my data, diabetes data, and after clicking on this link, this file, I will click on open and it will pop up this dialog. Click on OK. Okay, so this is, I mean, you can see I have uploaded this diabetes dataset. So you can do the same if you are uploading any dataset on this any file on Google Colab. So okay, so let's start. So a intro about this notebook. This notebook is intended for new users, basically for newcomers in this data science field. So this notebook seeks to do EDA on PIMA Indian diabetes dataset. So I will give the link of this dataset in the descriptions. So this user-friendly notebooks aim to conduct EDA on PIMA Indian data set. So this is it. And a brief about data set. This data set is originally from National Institute of Diabetes and Digestive and Kidney Disease. Okay, I will copy this and I will search on this Google so that you can know about this institute. So this is the institute. So okay, the objective of the dataset is to diagnostically predict whether or not a patient has diabetes based on certain diagnosis measurement included in the dataset. In particular, all the patients here are female, at least 21 years old of female Indian heritage. So this is about dataset and some more about dataset. The dataset consists of several medical predictor variables and one target variable, that is outcome. Predictor variables includes the number of pregnancies the patient has had, their BMI, their insulin level, their age, and so on. So this was about dataset and introduction about this notebook. So we will, use NumPy and Pandas for data wrangling, Matplotlib and Seaborn for the data visualization. So we will run this cell. I am using my mouse, so I will run this. I will run from here. If you are using your laptop keyboard, then you can hit on Control plus Enter. So it will run this cell. So I will run this cell, and it will import all these necessary libraries. Then again, we will load the dataset using Pandas. So I will click on this run button, which will load my diabetes dataset in a data frame called DF. And the second line, that is df.head, it will show me the first five rows of my DF data frame. So this is the first five rows. These are the first five rows of my DF diabetes data sets. So you can see there are columns name as pregnancies, glucose, blood pressures, skin thickness, insulin, and so on. The next is df.info. I will get some info about my data frame, diabetes dataset. So it will give me some info about my dataset. So there are total, 768 values, and in which total 8 columns are there, and in which last one is outcome. So that is a output level. So total 8 column for input level and one column for output level. So total 9 column, and these two columns are in float and rest are in integer values. So this is about info of this data set, and know more about this data. So in this cell, I have, I mean, given some brief about the columns of this data set. So the pregnancies tells us number of times when that person gets pregnant. The glucose column said like plasma glucose concentration, and the blood pressure tells us DBP, that is diastolic blood pressure. Skin thickness is our triceps skin fold thickness. Insulin is in like 2 hours serum insulin, and BMI you can everyone know like body mass index, that is weight in kilogram divided by height in meter square, and the other one is diabetes pedigree function. Like it indicates the function which is called likelihood of diabetes based on family history. So if someone in your family has this, history. If someone in your family have diabetes, then this function will tells like you have someone in your family that has uh, diabetes. So it is kind of indicative for this family members only. And the third and the last one is age, that is in years, and the output level, that is outcome. So it tells us whether that patient is diagnosed with diabetes or not. So 0 for no, 1 for yes. If someone is diagnosed with diabetes, then it will pop up 1, otherwise it will pop up 0. Okay, so brief about data. Let's describe this data. So df describe. So here you can see pregnancy level is having total 768 values. In fact, every column has 768 values. The mean of that those columns are given in this second column. The standard mean this, and minimum is this. Top 25% this, top 50% this, and the last one is max. So max value of a woman getting pregnant was 17. I mean, you can say, there is a woman who become pregnant 17 times. So this is about uh, describing our data set statistically. So one thing you can observe here, this is the feature glucose, blood pressure, skin thickness, insulin, and BMI all have minimum value of 0. So here you can see the minimum values of glucose, blood pressure, skin thickness, insulin, BMI, all are having minimum value 0. This is illogical because these values cannot be 0. Someone will always have a value of blood pressure greater than 0, and same for glucose, same for skin thickness, and insulin and BMI also. So this is illogically wrong that they have minimum value of 0. So we will see this later. Zero value rows must be either be removed or replaced with the median value, mean or median value of that feature. So this is we usually do when we have to do the data cleaning and data processing. So we will see it later. We will check the null values using this line of code. Df dot is null dot sum. So it will count all these null values. So let's run this cell. There are no null values, so we can move forward. So the next is a data visualization. By using data visualization, we can get some insights from this data set. So we will do the data visualization in two parts. First one is univariate feature visualization. The second one is multivariate. So in univariate, we will consider single column for the data visualization. So or single feature you can say. So we will first see the analysis of pregnancies. So this code will create three graphs. First one will be histogram, second one will be box plot, and third one will be violin plot. So uh, all the data will be from the pregnancy column, like pregnancy feature. So after running this code, you can see the actual graph, which will be uh, shown here as the output. So this is the graph of pregnancy feature. So you can see this graph is like this. It was higher on this left side and then lower on this right side, and it has some outliers also, like one, two, three. There are three outliers, and this violin graph shows us like it was first it was higher on the starting side, then it goes to down as the number of pregnancies are increasing. So there are very less people, there are very less women who are having more pregnancies. So this was all about this. Pregnancy analysis. So you can get this insight like there are very less people who are uh, having more number times of pregnancies, and there are, I mean, so many women who are pregnant or who are not pregnant. So this is all about pregnancies feature. The next one I will predict this. I will, print this number of uh, median and maximum values of pregnancies. So this cell will show the output of median of pregnancies and maximum values of pregnancies. Next cell will show us the value counts of pregnancies. So there are 135 women who have been pregnant for one time. There are 111 women who are not pregnant. There are 103 women who are pregnant two times. So in this way, you can see there are there is one woman who is pregnant 17 times. There is one woman who is pregnant 15 times, and there are two women who are pregnant 14 times. So in this way, you can see the value counts of pregnancies values. So the next feature, that is outcome variable, that is target variable. So we will run this cell and we'll do the count plot and also this pie chart. So basically there are 65% of women uh, who are not pregnant, and sorry, who are who are not diagnosed with diabetes, and there are 34.9% women who are diagnosed with diabetes. So you can say there are less women who are diagnosed with uh, diabetes comparing to who are not diagnosed with diabetes. So this is the outcome of this cell. So I have written this in the below markdown also. So the moving forward to analysis of glucose, I will run this cell and it will show me the histogram and box plot and Violette plot of this glucose feature on this data set. So you will see here. So you can clearly see this glucose histogram plot. There is one outlier here, and the graph is kind of normal. So it is kind of perfect for us, but there is some outlier. Like here you can see, here you can see, and here. So no issue. We will run this cell to get the median and max values of glucose feature. So median of glucose is 117, maximum is 199, mean is 120.89. So rows with glucose of rows with glucose value of 0. So we are counting the rows in which we have glucose value 0. So this code will tell us rows with glucose value of 0. So it is telling us there are 5 rows in which we have glucose value of 0. So and in the last line I have written this, there are 5 rows with glucose value as 0. This is not logical, so we need to keep it this. So we need to keep this in mind. I had said earlier also, like there is no one who has glucose value as 0, so it is illogical. So we move to next. Moving to next analysis of blood pressure. We will run this cell for the same, and here you can see there are so many outliers. So we will do this when we have to do data pre-processing. So here also you can see there are outliers 4 here, 3 here. So I mean you can get some idea like maximum values of blood pressure are between 60 to 80 for this diastolic blood pressure. So that is true also. Diastolic blood pressure normal range is between 60 to 80. So I think this is showing us correct values, but these are the outliers which we have to remove in the next step. So moving forward to get the mean, median, and maximum values of blood pressure, you can see the results. So rows with blood pressure value of 0, there are 35 rows who are having blood pressure value 0. So we will see it later. The next analysis of insulin. So we will run this code and plot the histogram, box plot, and volume plot. So you can see there are so many values which are having insulin value as 0. The maximum values are between 0 to 50, or you can say 0 to 100, 0 to 200. But there are very less values after 400, or you can say 350. So from these graphs we can observe there are so many outliers after values of around 350 or 360. So all these values which are more than 350 are basically outliers. So we can neglect all those values in the data pre-processing part, data cleaning part, or data handling part, whatever you can say. So the next is rows with insulin value of 0. There are 374 rows which are having insulin value of 0. Okay. Okay. So one thing we can observe here, like the rows with insulin values of 0 are 374. So the plot of insulins are highly skewed. So the zero value logical error is the most for this feature. That is 374 out of 768 instance having value of insulin as 0. So I mean this is was the most for which we have done in the previous. So moving to the next, that is analysis of BMI. So we will plot all those three plots for BMI also. I will run this cell and it will show me the three graphs. The first one, like in the bar plot, I can say there are some outliers which are having values in between 0 and 10, and after that I can say like there are some values which are having values more than 60 and 70. So these are the outliers we can see in the box plot also. So values less than 18 or 20 are outliers, and greater than 50 are outliers. So most of the values for the BMI are between 28 to 38. So that we can observe in the violin plot also. Median and maximum value of BMI are these. I can run this cell and we will get the values. So median of BMI 32, maximum of BMI is 67, and the mean for the same is 31.99. Moving to the next, rows with BMI value of 0 are 11. So these were the insight from this BMI feature. Analysis of diabetes pedigree function. So uh, we will run this cell and we will get the outputs. So we can see that values are skewed toward left side, and there are some outliers which are having values more than 1.5. So in the box plot we can clearly see the values which are having more than 1.25 are outliers. So there are so many values which are having 1.25. So after that I will run this cell to get the mean, median, and max. And one thing we can observe that violent plot distribution is dense in the interval for zero point 0.0 and zero point 0.1. Sorry, 1.0. So mostly values are between 0 and 1. So this is the outcome for this pedigree function. Moving to the next, that is analysis of A's. We'll run this cell and we can see here also the values are skewed toward the left, and there are some outliers which are having values more than 68 or 65. So there are some outliers in this feature also. The violent plot shows the same. Values are mostly in between 20 and 30. So moving to the next, mean, median, and max for this, I mean, age value. And median of age is 29, maximum is 81, mean is 33. You can say we again observe that the distribution of age is skewed on the left side. There are some outliers in the box plot for age also. Um, then We'll finish the univariate analysis here. We will move forward to the multivariate analysis, and where we will, compare the input levels, input features with respect to the output feature, that is our outcome level. Outcome level. So first we will compare the glucose with the outcome level, and I will run this cell that will plot a histogram, and you can see there are values which are basically, as the values of glucose increases, the count of patients having diabetes increases. It means values of outcomes as one increases. Also, after the glucose values of 125, here 125, there is a steady increase in number of patients having outcome of 1. So after 125, you can see there are so many patients which are having outcome as 1. So this is the level of 125 glucose level, and the count value is 0.04. So note that when glucose level is 0, it means the measurement is missing. We need to fill that values with the mean or median, and then it will make sense. So as I said, there are so many missing values here. There is significant amount of positive linear correlation, and that is true also, because glucose is highly correlated to the means diabetic, that person is diabetic or not. So this was the, whole insight from this first multivariate feature analysis. So the second is analysis of blood pressure with the outcome. So we'll run this cell and let's see what we get. So as you can see, there are so many uh, outcomes, and blood pressure do not have a positive or negative linear correlation. The value of outcome do not increase linearly as value of blood pressure increase. However, the blood pressure values greater than 82 count of patients with outcome as one is more. So here you can see blood pressure values greater than 82 count of patient with outcome as one. Here from here only greater than 82. So this one, and the next is analysis of BMI and outcome. Here also it is same like the previous one, that was glucose level, and it is also positive linear correlation between the BMI and this outcome. So these two are positively correlated. So moving to the next analysis of age with respect to outcome. Age is continuous, so plotting a histogram, and for age greater than 35 years, the chances of patients having diabetes increases as evident from the plot. The number of patients having diabetes is more than the number of people not having diabetes, but it does not hold true for ages like 60 plus above. There is some positive linear correlation though, so you can see here for more than, for ages more than 60, there is some positive linear correlation. The next is analysis of pregnancies and outcome. Here also the graph is same as above. There is some positive linear correlation for pregnancies with outcome. And in the end, analyzing correlations. So I will create a correlation matrix, then plot this as a heat map. So you can see here the glucose is You can see here like age is 0.2 for 0.24 correlated, and 0.17 for diabetes, 0.29 for BMI, 0.13 for insulin, and 0.075 for skin thickness, and 0.065 for blood pressure, zero point zero 0.07 for glucose, and 0.022 for this pregnancy. So glucose is highly correlated with the outcome. This is the thing we can observe here. And this you can see glucose and BMI and is the most affecting factor for having for someone who is like for predicting someone having diabetic or not, being diabetic or not. So we can observe glucose as the maximum positive linear correlation with outcome, which is logical, and the blood pressure has the lowest positive linear correlation with our outcome, and no feature has a negative linear correlation with outcome. So there is no feature which is having linear correlation. So I mean, this was all about our observation in this project. So next we can do that we can fill the missing values. So we will replace the zero values of the following columns with their median values. So glucose, blood pressure, and skin thickness, insulin, and BMI will be the zero values will be replaced with their median values. So we'll run this cell and replace all the median values, all the missing values with their median values. So after running this cell, I mean, I mean, I can say that all the missing values are gone now, and we will describe it here. So no minimum values are here. So for the glucose, blood pressure, skin thickness, insulin, BMI, and diabetes, diabetes pedigree function, there are no minimum values. There are no zero minimum values. So I think this is done here. With this, we replace all the missing values with their median of that column in the training set and use those learned median so to replace the missing values in the testing set. So this is what we had to do in this project. And once again, for the sanity check, I will check this if there is something which is null. So there is no null values. So I think we are come to the end. The future work maybe now we have some valuable insight which are helpful for us to create machine learning model. So if someone wants to go further and he wants to do more in this project, and then he can create do feature scaling, and he or she can create a machine learning model or classification model, anything what he wants to do with this data set. So thank you for watching this video till the end. I hope this was helpful for you. Bye bye.